Hi, yeah, in this brief video, I want to talk about how to use R as a scientific calculator to implement the formulas for statistic analysis. Okay, so the idea is to use calculator to implement formulas in statistics. So it's a formula-based approach so that you can understand what's really going on for behind the scene uh, when you run statistical software. Let me review operators in R. The basic arithmetic operators: addition, subtraction, multiplication, division, exponent, modulus, and integer division. Okay, so these are the basic arithmetic functions. You also got a relational operators: less than, greater than, less than, equal to, greater than or equal to, and equal to or not equal to. Okay. And you have a logical operators: logical not, element-wise logical and logical and, element-wise logical or, and logical or. So the element-wise logical and, well, element-wise logical or, they can be used on the vectors of logical values. Okay. Assignment operators, you have leftwards assignment. You get left arrow, double left arrow, equal sign. You have rightwards assignment, the right arrow, a double right arrow. Just want to say the double arrow left or right assignment, what this does is when you assign a value to a variable by using the double arrow assignment, then the variable value will be available across all the modules, the functions, the units of all across your entire R session, R program. Okay, so that's the global assignment. And also built-in functions in R, there are plenty. So you get absolute value, square root, ceiling, floor, truncation, round, and as signif. Okay, so you can find out the definitions by the help file or just read some documentation. Also, the basic function, you got a trigonometrical function: sine, cosine, tangent, and a logarithm with base 10, exponential of x, things like that. And then you have character function. You have substring, grep, sub, and string split and paste. Okay, these are more complicated than the numerical ones. Read the documents to find out their functions and the usage. Okay. Also paste to upper and to lower. This can come very convenient when you write expressions. And there are statistical and the probability functions. So the density function, the d-norm for normal distribution, probability function for the normal distribution, q-norm, percentiles, quintiles, quantiles of normal distribution, and you r-norm, you can draw random samples from normal distribution. Okay, and this is also same for other distributions like a binomial, b dot binorm, d Poisson. You can do d uniform, and also you have very simple statistic functions for mean, standard deviation, median, quantile, range, sum, and the differences, minimum, maximum, and scale. Scale is for standardization. So column center will standardize a matrix. Okay, so this comes very handy when you want to standardize a column or even a data set. Okay, there are other useful functions. For example, sequence SEQ, so generate a sequence indices, or rep, repeat x n times, or cut, divide a continuous variable in factor with n categories. Okay, so this is like categorization of continuous variable. Okay, so with all these built-in R functions, we can actually use a formula-based approach for performing statistical analysis. For doing so, by doing so, it will improve our understanding of statistics. So quadratic expression evaluation, so this is just demonstrating numerical calculations. We have 2x squared plus 3x plus 1. We want to evaluate it at x equal to 4. So first we assign 4 to x, and then we assign 2 times x squared plus 3 times x plus 1 to quad underscore result. And if you print out quad result, it should give you 45. Okay. Example data sample, if you want to generate a small data sample, you can just using the C function to create a numerical vector and assign them into data sample. Okay. And if you want to calculate sample mean manually, you have a mean function, but if you want to practice how to calculate sample mean manually, first you assign the sample size, which is the length of the data sample. And then you can say sample mean manual assigned as sum of the data sample, just add up all the elements, then divided by the sample size. Okay. And also you can use the formula to calculate the sample variance manually. Basically, you calculate the sum of all the data sample minus the sample mean, then take a square, then divided by n minus 1. Okay. And you can perform probability calculations. For example, you assign 10 as the mean and 2 as the sigma, the standard deviation. We're going to calculate the normal distribution for probability x less than equal to 13. Sorry. So probability is assigned as p norm. You get a 13 and mean equal to mu, SD equal to sigma. You can print it out, the probability, to get the probability value. Also, you can calculate the 90th percentile, the value at which 90% of the data fall below. So you can assign percentile 90 as Q norm, 0.9, mean equal to mu, and S equal to sigma. You can print it out the 90th percentile. Okay? And you can assign a sample data set using the data sample, assign a C, 8, 10, 13, 9, 12, 11, 9, 10, and n is the sample size. And then you can calculate the sample mean and sample standard deviation. Then you can calculate the critical value. So that's the Q norm at 0.975. That's for the 95% confidence interval, two-sided confidence interval. Okay, so 0.975 corresponds to the upper 2.5% tail. And then you calculate the standard error, which is the standard deviation, sample standard deviation divided by the square root of sample size. Then you can use the confidence lower and comes the upper. Use the formula as sample mean minus plus z critical times standard error. And then you can just print it out. The 95% confidence interval for the mean. You can round the CI lower to the 2-digit and to round the CI upper by to the 2 digits. Okay. And then we can try some more complicated implementation. For example, if we want to manually implement pooled or equal variance two sample t-test, the test statistic is t equal to x bar minus x1 bar minus x2 bar divided by sp square root 1 over n1 plus 1 over n2. Okay, and here sp is the pooled sample standard deviation. It is square root of n minus 1 times s1 squared plus n2 minus 1 s2 squared divided by n1 minus n2 n1 plus n2 minus 2. Okay, and n1 plus n2 minus 2 is the degrees of freedom. Okay, so let's try an example. You assign x1, x2, s2 data samples, and then n1, n2 are their sample sizes. You calculate the means and standard deviations. Then you calculate the pooled standard deviation using that formula. Remember this formula? Using this formula, you calculate SP as the square root of n1 minus 1 times SD1 squared plus n2 minus 1 times SD2 squared, and the whole thing divided by n1 minus n2 minus 2. Okay? And then you can calculate t statistic using that formula. Remember this formula? T statistic. and then it's mean 1 minus mean 2 divided by SP times square root 1 over n1 plus 1 over n2. And the degree of freedom is n1 minus n2 minus 2, n1 plus n2 minus 2. The p-value is 2 times, is two-tailed. Probability of negative absolute value t-stat and degree of freedom. And you can print out the t-stat, the degree of freedom, and the p-value. Okay, so that's the way you implement the equal variance version of t-test. And if you want to do the unequal variance t-test called the Welch test, then the formula is t equal to x1 bar minus x2 bar divided by square root s1 squared divided by n1 plus s2 squared divided by n2. And degree of freedom is a little bit tricky. You get df equal to this pretty complicated formula. But you can, using the same data, you can calculate the standard error, and then you calculate the t-statistic Welch, and then the degree of freedom, and then you can calculate the p-value, and you can print out the test statistic, the degree of freedom, and the p-value. Okay, so if you just call t dot test in R, you can easily implement the equal variance and unequal variance version of the t-test. But by using the formula-based approach, it will enhance your understanding of what's going on behind the scene when you do t-tests. Okay, that's the main purpose of this video. Thanks for watching.